Okay, so let's try this completing the square method with a couple of different examples this time to show how this all works. So on the left we have 4x squared minus 4x equals 7. Now the first step has already been done for us. We have a constant on the other side of the equation, and our job then is going to have to find a way to complete the square. Well, remember that to complete the square, the leading coefficient has to be 1, so our first task is going to be divide each of the terms on both sides by the leading coefficient of 4. So we're going to divide 4x squared by 4. We're going to divide 4x by 4. And we're going to divide 7 by 4 in this setup. And we're going to get a new equation that looks like x squared minus x, that would be 1x, equals 7/4. And so we're going to ask the question, what would we have to add to the left-hand side, and both sides really, in order to have a perfect square trinomial on the left? So what we do is we take the coefficient of the middle term. The coefficient of the middle term right here is 1. And we take that and multiply it by 1/2. Well, 1 times 1/2 is equal to 1/2. And then we square that. Well, 1/2 squared is 1/4. So we're going to add 1/4 to both sides to complete the square. So we'll get x squared, a leaky pen, we're going to get, let's try it again here, x squared minus 1x plus 1/4 on the left, and we're going to get 7/4 plus 1/4 on the right. Okay, we now know we have a perfect square trinomial on the left. We designed it that way, and we'd factor it as the square root of the first term, the sine from the second term, and the square root of the last term squared. On the right, we're going to combine our like terms, and we're going to get 8/4 over here, and 8/4 we happen to know to be a nice round number of 2. So we're going to use our square root property here and take the square root of both sides and say x minus 1/2 will be equal to plus or minus the square root of 2. Now, square root of 2 is not reducible. It's an irrational number. So we can't simplify that any further, but we can say that x will be equal to 1/2 plus or minus the square root of 2, which is actually two answers. If we were to write it out, we would be saying 1/2 minus the square root of 2 is one of our solutions, and 1/2 plus square root of 2 is our other. Okay, so that's our first one over here. Let's try the second one over here. We've got x squared minus 4x plus 6 equals 0. Looks slightly different, but some of the same methods can apply, right? Our first step would be to move our constant from the left-hand side to the right-hand side. So we subtract 6 from both sides. We get x squared minus 4x is equal to negative 6. Now, in order to complete the square right here, well, we'd have to have a leading coefficient of 1. And we already have that, so we don't need to divide both sides by anything. We're already there. If you have to see it, though, we can divide everything by 1. And if you recognize that the leading coefficient is 1, then we do have x squared minus 4x equals negative 6 already. The question is, what do we add to both sides in order to complete the square? Well, we've seen this before. We take half of 4, which is 2, square that, and we get 4, and so we add that to both sides of the equation equally. This time on the left-hand side, we factor nice round x minus 2 squared. But on the right-hand side of the equation, we are going to add negative 6 and positive 4. That gives us negative 2. And the issue with negative 2 is that, well, it's not a positive number. Can we still handle it? Oh, yeah. We can use complex numbers this time, because x minus 2 will equal plus or minus the square root of negative 2, and we recognize from earlier lessons that the square root of negative 2 is the equivalent of saying the square root of negative 1 times the square root of 2, which is I times the square root of 2, written in the standard form for an imaginary unit. So we're going to say x is equal to 2 plus or minus I times the square root of 2. And again, this is two different solutions. X equals 2 plus I times the square root of 2 in standard form, and x equals 2 minus I times the square root of 2 in standard form. Okay, more to come in the next video.